You keep hearing that you need complex frameworks or monthly subscriptions to build AI agents. I stopped using them for many use cases. Today I'm showing you the pure Python plus GitHub Actions setup I run for free. I show you exactly how it works and how to deploy your own AI agents. Welcome to Made by Agents, my name is Tobias and let's dive in. The first step is to skip the framework at all. Especially for simpler agents, a lot of different use cases, you don't even need a framework. You can just use a pure programming language like Python or TypeScript and GitHub Actions to execute your agents. And I'm going to show you how it works with a few examples. But the problem is that every framework comes with different types of costs. The first is a higher token usage, because every framework has layers of abstraction and some hidden tool calls and some retries that are called and system prompts and so on. And this just costs you more money at the end of the day because it uses up more tokens, and we all know that the AI APIs are not for free unless you're running everything locally. The second problem, you will face potentially more bugs. Not only the bugs your coding agent might introduce because it doesn't know all the ins and outs of the framework and the newest APIs and so on you want to use, but also bugs that are shipped with the libraries and the framework itself. And thirdly, a potential vendor lock-in that could be a monthly subscription, or that you're trapped in someone else's UI, or that you're limited to a set of AI models and you can't use everything. So whatever it is, that's just an aspect you need to consider. Here you see it again in a table. We talked about tokens and cost. The control is abstracted away in a framework. That's why it's called framework, because it's shipped with a predefined structure, which has pros but also cons. You can't customize it the way you want. And yeah, that's just what you need to consider and live with. Then debugging is maybe a bit simpler with a framework because it comes oftentimes with a tracing solution and monitoring inside the library that you don't need to code up yourself. Another vendor risk is that the framework might get abandoned in the future and not maintained anymore. And in this case, you might need to migrate away, which just means additional work for you. Then with the no-code solutions, you have less control over the cost and tokens. Oftentimes they add a margin on top of the token usage, or a monthly subscription, or both, and it's not always that transparent. You have almost no control. You're locked in user interface and you can't fully customize it or change it. And debugging is a black box. If there are some bugs in the no-code solution, you depend on the developer team of the no-code solution to fix it. The vendor risk is the highest with the no-code solution, and oftentimes you can't export or migrate away easily. You are locked in their system. With pure Python, you don't have these problems. You control the tokens, the cost, and how efficient your agents are running. You have basically zero vendor risk. As long as you're not using a lot of dependencies, you basically just have plain Python code, which is much easier for AI models to debug. And when you check out my website, madebyagents.com, you can find an agent cost calculator that I built a while ago. And here you can select your workflow shape, linear, multi-agent, or loop. And let's say we have a multi-agent system with a planner agent which calls different sub-agents. And here you can just estimate your retry rate and how many tasks you're running per day and how many calls you have and the different models you're using and the approximate amount of input and output tokens. And you can also add media steps like an image generation step or a video generation step, Grok Imagine Video, with the costs, and then you click on calculate, and you see here in one overview how much this will cost you per framework, and you see the differences here. With one framework you end up at $1.86 per task, and with the wrong framework you spend $17.82 for the same tasks and workflow. And you can see the differences just between different frameworks. And the costs, they consist of the model input and output token cost, the media generation cost, and the framework overhead. And you can see here that the framework overhead is the biggest cost factor. And then you also have retry costs. And you can see below a table with more details for each listed framework. Fewer dependencies means lower attack surface, less to maintain, and more control. That's why I like a minimal architecture. And this looks like this. You have a trigger. This can be a cron job, a scheduled task, or a webhook. And this runs inside GitHub Actions or your server. And this executes your Python scripts. And your Python scripts, they call some LLM, they have some reasoning steps, and then the result is posted to Slack, Notion, or any other app that you want. That's the minimal architecture and achievable with almost no external dependencies depending on what you want to build. And the nice thing about it is that it's fully customizable because we code it up ourselves. And we can just talk to our coding agent, Claude Code, Cursor, Codex, or Grok, or any other model, and it edits the code for us. Because we use a pure programming language, we don't need to fetch any external documentation and give it to our agent to understand what to do, to understand the newest API changes of this framework, and so on. The current frontier models, they were all trained on mountains of Python code, and this is why they understand it exceptionally well. To give you a few examples, one thing we could build is a security patch agent, and I sketched out the different steps how this could look like. Step 1 is it fetches fresh vulnerabilities from a public database and then matches this against our stack via the GitHub API. And for that step, we don't even need an LLM. We can just compare it programmatically. Then we have a cheap, fast model to assess the relevance, and then a stronger coding model to draft the fix. And then it opens a draft pull request via the GitHub API again. So this is even a multi-agent system where we have several models and agents involved. And to build this now, we just copy these steps as part of the instructions that we give our coding agent. Then we head over to our IDE and open up a terminal. And here we can now use Claude Code or Grok. Let's use Grok in this case. And we just start with our prompt. Implement an AI agent in pure Python with minimal dependencies. I want to use Gemini models and organize all the prompts in one prompts folder. All the config should live in one config file, all the agents in one agent folder, and everything else in a lib folder. And I want to configure it via environment variables. And now we also paste our step-by-step instructions here, and that's basically it. Yeah, when you do this, then you end up with something like that I have here already prepared. And you see here it put all the prompts in one folder. Then we have the config here in one file, and the different agents and capabilities. And very important, the GitHub workflow. That's actually what I forgot. So I would also say this should run via GitHub workflow or a GitHub action workflow. So very important. And then it creates this file here for you. And you can see here that this one runs every day at 6 o'clock. And it installs a Python version and then dependencies if we have any. And then it runs the security patch agent with these secrets. And that's the last step basically that we have to configure now, all these different secrets. And it created already this environment example file here. And what we need to do is now copy this file and rename it to just to .env. And now we need to set up these different environment variables. In this example, we need a Gemini API key. We get it from Google AI Studio. When we have an account there, we just create a new API key and copy the key and paste it in here. Then for the GitHub token, we need a GitHub account. We head over to our user settings and the developer settings, personal access token, and I recommend to create a fine-grained token and give it only the permissions that I needed. Click on generate new token, we give it a name here as well, and then we select the resource owner, the expiration for the key, and then the repositories that we want to use for this agent. And let's select all repositories in this case. And now we need just two permissions that are important for it to work. Contents, and we set this to read and write. So it means it can read all our repository content, or our code base, and it can also create commits and branches. And then we need the pull requests permission, and we also set this to read and write because our agent need to be able to create pull requests. And then we click on generate token and generate it, and then we copy it over and paste it in here as well. So now we see the Gemini models for the relevance assessment. It uses this one, and then these are just fallbacks in case this is offline. And similar for the coding agents, we select a slightly better model. And then here we have other settings that we don't need to configure, but we can. And here for the vulnerability database, we can set an API key for this database. This just gives us higher rate limits. When you search for it, you find this page here, and here you can enter your details and request an API key for higher rate limits. And then we have more settings here, more GitHub settings. And here, if we want to dry run it, we set this to true and run our agent, for instance, here on this local machine, then it won't create pull requests. It will just simulate it. Yeah, for testing, this makes sense. And then for production, basically, we set it to false. And now that's all we need to test this agent. So in this case, you can just prompt, hey, run a dry test or test this agent here locally, and see that if everything is working. And once we are done with it, we can push this to GitHub. And one step we need to do to run this in GitHub Actions automatically is to set up the secrets inside of GitHub. And then we can even manually trigger the workflow for testing. We head over to the repo where we push our agent to, and we click here on this repo settings. And then here we find secrets and variables, actions, and repository secrets. And here we need to enter all the different secrets that we use locally, or we generate a new key for GitHub and for the production environment. Yeah, so like this, and then add secret, and we continue with all the other secrets, also the models. Otherwise, it just uses the default settings if we don't set these here. But the API keys are mandatory for it to work. And once this is done, we can go to the Actions tab and click on the security patch agent workflow here. And then we click here on run workflow. And we can even also dry run it here if we want. And this will fail now because I haven't set up the GitHub token. This is how you can test it. And once this is working, it will be triggered automatically at 6 o'clock in this case. Otherwise, you need to just change this line of code here. Now, to give you another example, you can build research agents. In this case, let's say we want to research papers from arXiv, from this website here, where you can find all kinds of research papers. And we want an LLM to summarize 5 to 10 papers and then post a daily digest to a Slack channel. And it's the same procedure to build this out in Python, just with different instructions. And one difference in this example is that we need to integrate Slack so that it's able to post this automatically to a Slack channel. And I can quickly show you how to do that. The easiest way is to set this up via Slack webhook, and you will have something like this. Your agent will set this up already in the example environments, and you need to provide a Slack webhook URL. That's all to get this working. When you go now to your Slack account, you can create a new channel here, and I already did that, and I called this arXiv digest, and you can see how this will look like. It will just post these summaries here with the link to the paper and even the link to the PDF of the research paper. And once we have this channel set up, we head over to api.slack.com/apps, and we create a new app here from scratch and give it a name. Let's say arXiv agent 2, and we select our workspace here and click on create app. There are a lot of different settings that you can change here, but the relevant for us is the incoming webhooks, and here we turn it on. And now we click on add new webhook. And now we need to select the channel for the webhook where we want to post the results, and we click on allow. And now this app is connected to our Slack channel. So we can see it here below now that arXiv agent 2 was added as an integration to this channel. And here we see our webhook URL that we copy here and paste it in here. And now that's all. And now it's set up and it will post this to Slack. And the same secret we have to add to our GitHub secrets here as well for the specific repo of this agent. And this way you can build tons of different agents, tons of different use cases. One agent I built, for instance, is a social signal agent that analyzes my social profiles and just sends me a Slack message if there's something that is important to respond to. And yeah, you can see it here. In case it finds something, it mentions it here and I can respond to it. Another idea is a content research agent. This one researches X and YouTube for the newest trends and then also sends me a digest to Slack, even in the structure that I like, with different title ideas, description tags, and so on, so that I can use this for YouTube directly. You can also build pull request review agents, daily briefing agents that's sending you weather and news and tasks and analyzes your calendar, an uptime monitor for your systems, or a competitor intelligence agent that watches your competitor, whatever. change logs and announcements and so on. So the sky is really the limit here. A few things to keep in mind to keep the attack surface low and to keep it safe is to set up these tokens only with the needed permissions. The way I showed you, for instance, for the GitHub token, only give it the permissions that it really needs. For these API keys, you can set rate limits or spend limits. Use that as well. Then never commit the secrets that we have locally here. Yeah, don't add them to your code. So you see here that this is git ignored. Normal developer practice to not commit this. Make sure your repo is set to private if you don't want to make this open source. It's relatively safe to set up these secrets in GitHub. You only need to trust GitHub in this case that this is not hacked. Then for critical tasks, keep a human in loop and review your agent output, and also validate the output and check if all the fields are correct before you switch this live. Then you can also add audit trails via logs, some external dependencies or other solutions, or you code it up yourself. And then you can trace exactly what the agent is actually doing and what's going on in the background. You can see here in this requirements.txt that I use 0 external dependencies for this agent, just the standard Python library, and I could easily add a logging feature to this. And lastly, keep an eye on the cost. Just coding this up yourself doesn't mean it is cheaper than using a framework or a no-code solution, but you can make it smaller and cheaper if you want. And you can track this in different places depending on what LLMs, APIs you're using, or if you add an external tracing solution to it. Now it's time to try it yourself. Thanks for watching. And if you want to learn how to build an intelligent document pipeline, then watch this video here next.